So some of you were just adding them up by hand. Some of you were starting to use Excel but just weren't quick enough to quite get your answer. Some of you got really close to your answer, which is good. What I did on Excel first, now you're not going to have Excel to do problems for you. I'm going to show you shortcuts on how to do this here in a second. But on Excel, I entered $1,000 here in this cell. And then in the cell right below it, notice what I did. I hit equals previous cell plus 10,000, right?
Oh.
And then if you just copy that and paste all the way down, it'll show you how much you get all the way through until that very last day. And then if you want to add everything up in Excel, I showed you this the other day. There is this summation notation or sigma notation. You can choose that and you can sum, and then you highlight all those and add them together. Okay? Undo. Now I've messed it up. Alright, so that amount ends up being $4,681,000. Okay? Well, yeah, I'd be fine with that too. Okay? The other amount, okay, my rule was I entered a penny on the first day and then I just said take the previous cell times 2. So it keeps doubling it over and over and over again. Okay? And then again, that's how much you got. Which some of you guys figured this out, how much money you get on the 31st day, because you used your geometric rule to determine that. Okay? Use your geometric rule to determine how much you got on the 31st day. You got over 10 million, but to add them all together again, what I did was, as you can see right here, I did the sum from B3 to B33. I told Excel to add all those together. Okay? Now, you're not going to get to use Excel, but I was kind of hoping that some of you would at least try Excel a little bit to add all those together using the summation notation. Okay?
You should say Google Excel. We just went straight to
Yeah, that's different.
I was letting you try. But overall, not too bad. Alright, so I want to show you how we can do this, though, without Excel. Okay? So, now I got some notes for you. Alright, the first situation. The first situation. What type of sequence of numbers is it?
Geometry.
The first one. 1,000, 11,000, 21,000, 31,000, 41,000, 51,000. Arithmetic. Why? You're adding the same amount over and over and over again, right? Okay. So, if you want to find the sum of a finite arithmetic series, okay, here's how you're going to go about doing it. Okay? I'm going to show you a little proof here. You don't need to write the proof down. I'll show you how the formula works, though. Okay? So, S sub n represents the sum of all the numbers. Okay? In a arithmetic series, we're going to add all the terms together, right? We're going to add all the numbers together. What's the first term always? A sub 1, right? Okay? What's the next term? A sub 2, but let's write it using A sub 1. A sub 1 plus the... How do you get to the next term in an arithmetic series? You add the what? Well, you add the 10,000, and 10,000 was the difference. You add the difference each time, right? So whatever A sub 1 plus the difference is. What's the next term? A sub 1 plus the difference plus the difference. So how about 2 differences, and so on. A sub 1 plus 3 differences, plus a sub 1 plus 4 differences, all the way until we eventually get to a sub n, right? Whatever the last term is. Okay? Now I'm going to write this backwards, right underneath it. I'm just going to start with this term, right? So the last term. What would be the term right before the last term? A sub n minus the difference. What would be the term right before that? Minus the difference twice. All the way until we get eventually all the way back to the first term. Okay? So I just wrote this 2 different ways, right? Like 1,000 plus 11,000 plus 21,000 plus da 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 da, or start at the very back end, the last number plus the one right before it plus the one right before it. I just wrote it 2 different ways. Everybody see that, what I did? Questions? Okay. I'm going to add these together. S sub n plus S sub n is 2 S sub n. Agreed? A sub 1 plus A sub n, okay? A sub 1 plus A sub n. What if I add these 2 together? What do you get?
Don't they cancel out?
The D's do, and what do you got? A sub 1 plus A sub n. How about here? A sub 1 plus A sub n. How about all the way till the very end? A sub 1 plus A sub n. So really I'd just be getting this over and over and over again. So this plus itself how many times? Well, in our example 30, but in this example,
So raise it to the nth power.
no, don't raise it. We're not multiplying. We're this plus it again, plus, plus, plus. Repeated addition is not exponents.
Not to the end, but
Times n, right? Because aren't there n of them? Right? Wouldn't there be n, a sub 1 plus a sub n, a sub 1 plus a sub n, a sub 1 plus a sub n, all the way until you get to the last one, which was how many terms? N. There were n terms. So a sub 1 plus a sub n times n, because there's n of them. However, in this case there was 30 of them in our situation, right? Divide both sides by 2. And S sub n equals a sub 1 plus a sub n times n all over 2. There's your formula that you can use to add together every term in an arithmetic series. So for our example, how many terms were there? 31. So the sum of the 31 terms will equal the first term plus the last term. So the first term was 1,000. What was the last term? 301,000. Now, in order to have figured that out, you either had to keep adding 1,000 over and over again, or just use what?
Equation.
The rule, right? A sub n equals your first term plus the difference n minus 1 times, right? You could use that to figure out the 31st term, which a lot of you had done. Okay? And then how many terms are there? 31. Right? That's what n represents, the number of terms that there are. So get a calculator real quick. Okay?
Yeah, still recording.
Okay. Get your calculator out real quick, do that. And let's make sure we get the same answer that Excel got for us. What do you got? 4,681,000. Perfect. Yep. 4,681,000.
Yep, he's right.
So even a little quicker than Excel, unless you're good with Excel, obviously. If you're good with Excel, you can rip that out real fast. Okay? This will always work.
It's recording.
This will always work for the sum of a finite arithmetic series. Okay? This will always work. As long as it's arithmetic, and you want to add the first 30 digits together, the first 50, the first 100, as long as it's finite, means it comes to an end, you can use this formula to help you. What does the a sub 1 represent? First term, a sub n, last term, n, number of terms. Okay? Alright, so there's sum of a finite. Everybody got that? I'm just going to shut this off. I'll have to get the rest another time.
You have to hit dismiss first.
There's 10%. I'm going to keep going. Everybody got this one? Okay. Tell me when it gets to 5%.
Okay.
Next one. Sum of a finite geometric series. Okay? I'm going to show you the proof. You don't need to know the proof. Okay? But the sum of the n terms of a geometric. Alright, what's the first term? A sub 1. What's the next term? A sub 1 times the...
Difference.
It's not called the difference. The ratio. A sub 1 times the ratio, right? A sub 1 times the ratio times the ratio. So a sub 1 times the ratio squared. Plus a sub 1 times the ratio cubed. Plus all the way until I get a sub 1 times the ratio,
34.
well, not n. So how many times would you have to multiply it by the ratio to get to the nth term? N minus 1 times. Remember how it's always one less? Isn't that the rule for the nth term in the geometric?
Yes.
Okay, it's kind of important you know that. Alright? Now, I'm going to subtract r times s sub n. Okay? So really, I'm taking every one of these and multiplying it by r, alright? So r would be r times a sub 1. If I take this, minus a sub 1 r squared minus a sub 1 r cubed minus a sub 1 r to the 4th, and then minus a sub 1 r to the nth. Okay? So this minus this, that would be s sub n times 1 minus r. And you'll see all of these would start to cancel out. And you'd be left with just this a sub 1 minus a sub 1 r to the n. And again, I'm going to pull out an a sub 1 from each term. I'm going to divide by 1 minus r. And I get s sub n equals the first term times 1 minus the ratio to the nth over 1 minus the ratio. That's your rule for finding the sum of a finite geometric series. Okay, you don't need to know the proof, I'm just showing you how it works. Okay? So that's how you can add together all the terms in a geometric series, which was option number 2, right? Okay? A sub 1 is your first term, r is your ratio, N is the number of terms you're adding together. Okay? So the sum of those 31 terms would equal what?
0.01.
Our first term was 0.01, right? What's our ratio? 2. So 1 minus 2 to the n. 31st, weren't there 31 numbers we're adding together? All over 1 minus 2. Go ahead, use your calculator, see if you can get the right answer there. I would do 1 minus 2 to the 31st power, get that answer, divided by, make sure if you don't do this part in your head, you put parentheses around the 1 minus 2 because you're dividing by whatever 1 minus 2 is. Personally, I would just divide by -1. I know that's complicated for some people to do that math in their head. Okay. But I get 1 minus 2 to the 31, get that answer, divided by -1, then take it times 0.01, and you should get the answer that Excel had of about 21 million. So, anybody confirm that? Is it working out for them?
21 mil for.
Alright, good.
So
So there's the sum of a finite geometric. Okay? And one last thing. I'll explain why in a minute, but I just want to put this on the same video. You can add together the sum of an infinite geometric if the ratio is less than 1. Okay? The sum of an infinite number of numbers will equal the first term over 1 minus the ratio. The sum of an infinite geometric series will always equal the first term divided by 1 minus the ratio, as long as the ratio is smaller than 1. And I'll talk about that a little bit here after I shut down the video, because we're out of juice.